So today's lesson is equations of proportional relationships. So equations of proportional relationships. And remember, all of our main focus for this entire unit is focused around unit rates with fractions. So as we work through today, we're definitely going to encounter some fractions. So in example 1, it says Rashid is trying a new recipe for his family. The table and graph below show the cost of the mushrooms needed for this recipe. We need to figure out the unit rate of cost per pound. And so we also, in order to do that, have to finish the table. So let's go ahead and look at part B first. So if we buy 0 pounds of mushrooms, it's going to cost us $0. A half pound is $4. So if a half pound is $4, I know a full pound would be $8. Because to go from 1/2 to 1, I multiply by 2, so I multiply by 2. And then if 1 pound is $8, 8 times 2 is 16, so 1 times 2 is 2 pounds. So by watching for that pattern, we're easily able to fill in our table. And then it says the unit rate, remember, is per 1. So I'm looking where it's per 1 pound. Get my highlighter, 1 pound, and I have my corresponding cost. Because the unit rate is always going to be 1 on the bottom. Because it's per pound, that's per 1 pound. 1 pound is $8. So there's my unit rate. I finished my table, and I have my graph that they built for us. So looking at this and the rest of these questions, it asks us, is this relationship proportional, and how do I know? Well, because we were provided a graph, I can use what I learned in my the last unit, and I can say yes, and it's because the graph, remember proportional graphs have two qualities, is a straight line through the origin. Remember, it's that straight line and it goes through my point 0, 0. So I know it's proportional simply by looking at that graph. My next question is write our equation. So remember, back in our last unit, our equations always followed the pattern y equals kx. The letter K was our unit rate. Remember, we already established my unit rate was $8 per 1 pound. So my relationship is y equals 8x. And then it asks, what does the point 216 mean in context of this problem? So we have 2 x's, 16 y's. Really all we have to do, remember, we talked about we just put labels on it. If I have 2, my label on x's is pounds of mushrooms, then it will cost $16 because the y is dollars. So these problems are very similar to what we've done in our previous units. So looking at example 2, TJ's mom entered a 10K run. The family wants to support her by being along the course and to meet her at the end. She previously ran a 5K in 1 1/2 hours. If she runs at this constant rate, help the family figure out where she will be at different times. Now, because we don't have a table to look at, we're going to figure out our unit rate first. And we're looking at kilometers per hour. So kilometers goes on top. Per hour is on the bottom. The numbers I'm given are 5 and 1 1/2. So just as we've been talking about this week, we're going to do 5 divided by 1 1/2. Make it improper. 5 divided by 3/2. KCF, 5 times 2/3. And because my 5 is not a fraction, I can put it over 1. And then we just multiply straight across. I get 10/3, which is the same as 3 1/3. So her unit rate is 3 1/3 kilometers per hour. So now I have to put this in my table. I know that if she spends 0 minutes running, she's going to go 0 kilometers, right? It doesn't make sense otherwise. If she spent 1 hour running, we figured out she goes 3 1/3 kilometers. So then if she runs for 2 hours, we're going to have to add another 3 1/3. So 3 and 3 is 6, 1/3 and 1/3 is 2/3. 3 hours, add another 3 1/3. 6 and 3 is 9. 2/3 and 1/3 is 3/3. But 3/3 is really 1, so it's a solid 10 she would go. 4 hours, add another 3 1/3, so we get 13 holes, and then we have 1/3. And then 5 hours plus another 3 1/3, so I get 16 2/3. So now that I have my table built, I can go ahead and graph this. So my graph is already set up for me, so we're just going to fill in what we can. We have the point 0, 0, 1, 3 1/3 we have to estimate. 2 is 6 2/3. 3 is an even 10. And then 4 is off my chart. So I'm just going to connect the dots I have. And I drew it freehanded. It's not perfect, but it is a pretty decently straight line. So using that graph, it asks, what kind of relationship is this? Well, it's a proportional relationship. And it's because it has a constant of proportionality or a unit rate. We figured that out first, and so because we use that to build my table, it's definitely going to be proportional. Part E asks for that equation, so remember y equals kx, but k is going to be my unit rate. So it's y equals 3 1/3 x. Or you could also use the improper fraction, y equals 10/3 x. Both of these are the same number, just one's a mixed number, one's improper, but both would be correct answers. We don't want to change it into a decimal though, because that's going to be a repeating decimal and it's not going to turn out very well if we would try to answer a question with it. And then lastly, what does the point 2 and 6 2/3 mean? So remember, 2 is my x, 6 2/3 is my y. 2 is my hours, 6 2/3 is my kilometers. So if she runs for 2 hours, then she will go 6 2/3 kilometers. I like to write my sentences as if, then, if being the x value, then being my y values.